And if you looked at this and plotted the density function, f of n, it would go from minus a to a, and the density function has to have a value of 1 over 2a here. Do y'all follow me? It's going to have that. Y'all agree with that? As a matter of fact, what I can do is get rid of this k and just go ahead and take 1 over 2a out in front, because that has to be the magnitude of it, the value, f of n. Do you all agree, class? Just take a moment. I mean, does everybody follow me how I reason that out? Because the area under this curve has to be 1. If it's a constant, then the width times the height has to be 1. This is 2a, this is 1 over 2a, it's 1. Okay? Now, to get the value of a, we go here. And we see that this is equal, sigma n is 12, and it's equal to 1 over 2a. And then we integrate x squared dx, we get x cubed over 3, evaluated from minus a to a. And that's going to be 1 over 6a. And we get a cubed, because 2 times 3 is 6. And then we get a cubed minus a cubed, which is going to be a plus, and the net result is plus a cubed. And that boils down to a squared times 2 over 6, or a squared over 3 is equal to 12. Here that means a squared is equal to 36, and a is equal to 6. Y'all agree with this? That's the only way. I'm just showing this one time, but if it's a constant density and they don't give you the limits of it, you can get it if they give you the variance this way. It's a zero mean, though. That's the key. Y'all with me? Any questions about this? I put the solution up, but I want to make sure I go through it bit by bit, okay? Now that we have that, the f of n, this is f of x we've got, f of x. Now we have to get, he asked for the conditional probability of f of x given y, doesn't he?
Yes.
All right, now this one, so if we think about it, f of x, where y is known, I'll just call it y equals a constant, k, for lack of a better term. Well, that's equal to f of y given x times f of x over f of y. And again, I'm just using the formulas in the book. We could rewrite this right here as what? As just f of x comma y. Do y'all agree with that? Everybody with me on this? And that's another way we could render that. All right, so we've got f of x right here. That's given. And by the way, I didn't say this, but this is true for 0 greater than x less than infinity. In other words, this has no values for negative values of x if it's a Rayleigh. Y'all follow me? It's real important to appreciate that because it's going to affect the answer. Now I come over here. Next thing I have to get is f of y given x. And here I go over to this thing, and this is stated in the book. I didn't say this effectively last time, I don't think, but I want to make sure I do for the time before. When I look at this, remember, these two are statistical. This is not. That's observable. So if they give you x, right?
No, they give you y.
Or, I'm sorry, they give you y. No, but I mean for this part right here. I need f of y given x. You'll follow me for this part? Everybody with me on this? I'm sorry. I'm trying to get that part right there. I've got the f of x, and once I get this part, then I have f of xy, and to get f of y, I just integrate that over where x exists. Do y'all follow me? Okay? So, without getting too confusing, this one, if you look at this, we need to, so x is going to be given, and therefore if I look at this, the noise will be equal to y minus x. Now, I can say this, we're assuming that x is given, that's known, right? We want f of y, we need the statistics for y. So I take that over here, I have y minus x is equal to noise. Now I plug that value in to this right here. This is going to be y minus x, not there. I should have written the functional form of this. I'm gonna do it. I know f of n now is equal to simply 1/12, and this is for n greater than -6, less than 6. Do y'all agree with that? In other words, it's 0 else. This is 0 else. This is the noise, because they said it's evenly distributed and they give you the variance. Take a moment, just appreciate what I've done. I don't want to run through this one, but I got other things to, but you all with me on this one? Just show of hands, how many understand this part? Anybody have a question about it? I'm not seeing a whole lot of hands. Do you follow me, Sam? Any questions? Because this is a good problem.
So it's always expected value of x squared or n squared to get.
Well, remember, this is the variance, right? What is the variance always? Variance is always the expected value of the function, typically x minus the mean squared, right? It's the expected value of that. Here, the mean is 0. So it's just n is the variable, it's just n squared. That's the reason. Y'all with me? We come over here, and that means here, this is equal to 1/12, right? For what? Now n becomes y minus x, so this is true for y minus x greater than -6, less than 6, and it's 0 else, right? You all agree with this? So it depends what x is, obviously, right? If we wanted to keep on manipulating this, what do you end up getting? And it doesn't matter to me how you do this, but we're going to need, if we're going to do this part right here, I mean, that is true, but we would like to have it in terms of just what? Well, let's do it this way. I need to get f of y, right? Do you agree with me, everyone? So what is f of y? Fy of y technically is an integral of that thing right there. So I'm going to say it's going to be 1/12 is there. And the limits, how would you do these limits, guys? How do you want to do them? This is going to be an integral with respect to x, right? So where does x go from? How about if we go ahead and change, we'll multiply through by -1, and that means 6 is less than x minus y greater than 6, -6. Do you agree with that? You multiply through by -1, right? You change the, if it's greater than, it becomes less than, correct everyone? And then what happens? Remember, we want x, so if we add y to it, we get 6 plus y less than x greater than y minus 6 here. Do you agree with that? Follow me? The integration is going to be here with respect to x. So I have that, and so my limits go from y minus 6 to y plus 6, and then I put in the density function for f of x, and that's that one, so I put in x over sigma squared, and then it's going to be times exp to the minus x squared over 2 sigma squared, and it's dx, and that will be f of y. Do you all agree with that? Now when we do this integral, you're going to see, I don't remember if he actually evaluates that, but you're going to see that what does this become? It becomes f of y. Here you're going to get the 1/12, 1 over 12 sigma squared. Those are the constants. Then when you have x e to the minus x squared over 2 sigma squared dx, you get minus e to the minus x squared over 2 sigma squared. You all remember the antiderivative, right? In other words, if you take u equal to e to the minus x squared over 2 sigma squared, du becomes, it's going to be e to the minus x squared over 2 sigma squared. The derivative of this is going to be minus 2x over 2 sigma squared, or the 2's go away, and you get this, and this becomes that. Do y'all follow me? Take a look. Do y'all see this here? What is this right here? Well, it's this right here, right? So that means when you integrate that, you're going to get minus that, so technically it becomes minus e to the minus x squared over 2 sigma squared evaluated from y minus 6 to y plus 6. Just showing, y'all agree? This is show, how many looked at this problem, by the way? All right, y'all recognize what I'm doing here, why I'm doing it. With me? You're suspicious, I don't like this. I just don't. Now to evaluate that, what would it be, f of y? I should say something here. I gotta say this. The low point here cannot be lower than 0. Y'all follow me? It can't be negative. Y'all with me? So if it was negative, this would start at 0. If y minus 6 was negative, it would start at 0. And I think he asked for y equals 0, 6, and 12, I think. So for the first part, if it's 0, this part here would start at 0, right? And it would go to 6. Y'all hear me? So that would be one value. This would be a constant. Do y'all follow me? The next one, he says y is equal to 6. It still is going to start at 0, but then it would go to 12 here. Y'all with me? I mean, do you follow me on this, class? How many do? Finally, he asked for 12. When it's 12, it starts at 6 and it stops at 18. So there's 3 different values for this. And we could write down the actual values, but that right there is correct. And if you go ahead and do this, you can just make this negative and make this positive, and then put simply a u of y minus 6 here. The u function is only going to have a value of 1 for this argument equaling 0 and higher than that. Y'all follow me? So you can just do that and multiply it by that, and now you're fine. And then there'll be 3 different values for f of y. It'll be fy of 0, fy of 6, and fy of 12. I'm not worried about the evaluation because those are constants. But when we go up here, this is f of xy. Now let's see. I've got this here, and I put that in here, so let me put it right here. I think I can get all this in. So then, now we have f of xy of x given y, and it's going to look like, so it's 1/12, and then it's going to be times that exp to the minus x squared over 2 sigma squared times x. Where's that? Oh, I erased the thing. It's times x here. And this is going to be true for, and it's divided by f of y. And it's true for that condition. For x greater than y minus 6 less than y plus 6, with the caveat you have to have a functional form u of x here. So it can't, yes sir.
In the denominator, should be 12 sigma squared? Or not?
No, you're right. It should be. I'm sorry about that. That's 12 sigma squared, because this is, I erased it, but it's this density function I got circled right here. Sorry. You all with me, class? How many see what I'm talking about here? All right, now, if you look at this, he gives you 3 conditions. He wants you to plot it for 3 conditions. The first is x. He just wants this plotted from over the range, and he gives you it for y equals 0, right? Well, when y equals 0, I'm sorry. Yes, for y equals 0. Well, that means if this thing is 0 right here, this is actually going to be what? I mean, this is the negative, right? So you have to start the whole thing. I'm putting this, and I should put, this is going to be a function that's going to affect the validity of where this is. It has to be positive. This is the only time this function right here is going to have a non-zero value. That's what I'm saying. You all with me? So for the first one, for y equals 0, here you're going to evaluate f of y over here. You start There'd be 0 to that, and y is, sorry. Yeah, there'd be a minus 6 there, but you put it in there, you're going to get 1 minus e to the minus, 1 minus e to the minus, it would be 6 squared over 2 sigma squared. Y'all follow me on that? Everybody with me? But it's a constant. And what it's going to look like, it starts at 0 and it'll go all the way, and he should have it at 6. I think in my book it shows you this. And this would be f of x given y, and here y is 0. Do y'all see that, class? Just a sketch, right? And now, what is the most probable value of a Rayleigh function, by the way? Do you remember?
One is sigma.
It is sigma, right? It's the Gaussian sigma. Y'all hear me on that? So the most probable value is actually sigma for this, right? Now, what's the, and we got sigma, I didn't put it in there, but did I show you? I had it, but what was it? They had, the mean was, what? 10? So 10 is equal to square root of pi over 2 times sigma. We can get sigma is equal to really what? Square root of 200 over pi, right? If I take the 10 inside. Do you agree with that? I don't know what it is. Can anybody
It's
tell me?
7.979.
Thank you. 7.979. So that would be this point. Wait a second. That's the truth. This doesn't start going down, it's just going up. We're not even hitting the mean. It should look like that for the first one, all right? Because this is 6 here, and the mean is out here. That would be sigma. Do you agree with this, class? Now the next part is for y equals 6, right? Does everybody follow me what I'm doing? I'm trying to just follow the form exactly, but you have to get that standard deviation. You have to get the actual value of a, the width of that thing from the standard deviation, or sorry, from the variance. Y'all with me? And then from that, the only thing you have to do is make sure the limits here agree with what the book says for y. So then they say they want the density function if y is equal to 6, right?
Yes.
The only thing different is you're going to have a different value here, because now when we evaluate this, the lower limit's going to be 0, the upper limit's 12. Now I'm going to tell you what it means. See this, when you think about this, if I integrate this function, you have to have 1, right? Y'all with me on that, class? Well, what that f of y does, it scales it so that the area under this curve when integrated will be 1. That's the only thing it does. Okay? Y'all with me on this? Or not? Did you have a question?
I got lost in the
What don't you understand? Because you're probably not alone. I'm not trying to whip through this, but I'm trying to hit the essentials. Go ahead.
there's nothing you did wrong, I just honestly got lost.
Well, I
Following
mean,
along.
you understand this part. This is the critical thing, right? Now, the next critical thing is know how to get f of y given x, because if x is given, the only statistical thing, the only thing that's given statistically is the noise. And since y is observed, you can get f of y given x by simply saying y minus x is the noise and taking that and putting it into the f of n, right? Replacing n with y minus x. Do y'all follow that part? How many understand what I'm doing here? All right, some of you don't. Chase, no? What don't you understand? And I'm desperate to try to help people, but the biggest problem I have is I'm not sure what you don't understand. Help me understand what you don't
I think
understand.
it's going from the original formula and then after that.
Let's try this way. And I admit this problem is tricky because there's a lot of things going on. The first tricky thing is you have to get, in my opinion, you have to get A. That comes from the variance. Did you understand that part? That's the first. So now we know where the noise exists and what its value is. Do y'all follow me? The next tricky part is to get this. All right, now that is something where I have to take f of n that I have here and replace n with y minus x. Do y'all follow me? Chase, you with me on that? Because y is observable, they want f of y given x. X is given. The only thing that varies is the noise, but we can say the noise is y minus x. So now we have this, right? And you'll notice it's constant. So the only thing we need to do is figure out where it exists. So this right here has an existence limit. It has to be for y minus x positive, greater than or equal to 0, and then you have the upper limit on it. With me on that? All right, so those two come out, they're okay, right? This one, f of y, you take this is xy here, and you have to integrate over x. That's this, but you'll notice these are the limits. Y'all with me on this? Because that's the noise integration we're doing, but we have to have the firm limits on there for positive values. And so for this one, now you got the limits on that, but this is the actual Rayleigh distribution. When you integrate this, you get this, guys.
And then, how did you flip the y minus x and y plus x? Like, what caused you to do that?
Go from a to minus a of x, or f of x dx, right? This is the same thing as minus the integral from a to, or from minus a to a of f of x dx, right?
Okay, you just did that to get rid of the negative in front of it.
That's the only reason I did it, right? Y'all follow me on this, class? Just to eliminate the negative. Now, this thing right here, though, the only thing it does is scale the height of this. When we take a look at this, this is, if you think about this, this is really f of x. It's got an f of x, f of y given x over the f of y. The f of y just scales this thing, so the area under this is 1. That's all it does. Do you all with me, class? The signature of this will look the same. Okay, how many, did that help at all?
Good.
I hope so. You don't have to lie if you don't. I mean, there's probably little things that you feel, if you haven't worked through this problem, the details get into the weeds, there's little things that you're wondering about. Mainly the limits, that's the thing that'll get you at the end of the day. That's what I had to think about deeply. Now, when I get all this, that's the first one, right? What's the next one? Can I just erase this? All right, let's just do the next one, because I want to show you the 3 plots. Some people are probably thinking, are you going to ask us to plot that thing on? No, not on this quiz. On the final exam, I may give you something that requires you to plot it. And I'll give you a secret on how to do it later. But it really boils down, figure out 2 or 3 or maybe 4 values from your calculator. Just put the points down and connect them. Really, yeah.
Technically, this is just 3 different conditional probabilities.
That's right, for 3 different values of an observed y. All right, so they're the density function, all right? Not the probability, it's the density function, f of x given y. If we observe y, what would the density function of x be given that observation? That's all it's asking for. The probability would be the integral. If you want to, before I move on, if y is given as 0, this would be this one, right? So if they ask you, what's the probability of x being less, or being greater than 0, less than some value that's less than 6, it'd be that integrated from there to there. Do y'all follow me? You all with me on this? That's all it is. And if I integrate from here to here, I get 1. Did that help at all?
Do you, by any chance, have like, could you post like your, did you work this out earlier that you could like post it again on, when that maybe this solution?
Wait, in the solution posted, guys?
The solution on here is like, it doesn't tell you how you got 1 over 12. It skips a lot of major
Oh,
steps.
all right. I sent this to somebody, you. Tell you what. What? Would you do me a favor? Could you email somebody? Why don't you, or anybody, email and say, Dr. Baginski, please post your entire solution for 3-2.1. It's really telling. It's a good problem. It goes through everything that can destroy you. They got different limits, different density functions, and they have different conditions for y, or the observation, and they ask for the density. You with me on this? Now, I'm going to do the next one right here. It's a good problem. I wish I spent more time with the last one. All right. So, next, what happens when y is equal to 6? All right, first, come over here. Here's f of y, right? Now, f of y, when y is equal to 6, it goes, if you think about this, it goes, that's 0, and that's going to be 12, and then I didn't flip them, no, I did, I'm sorry, this is y plus 6, so this is going to be 12, so it goes, now this is going to be evaluated, you'd have 1 over 12 sigma squared here, And then this would be, at 0, it's 1, minus at 12 here, it would be e to the minus 12 squared over 2 sigma squared. Y'all agree? And it's going to be a bigger number than it was when y was 0. It's larger, but it just scales it. So when you get that, now this function here goes all the way out to 12. Do you agree with that, from 0 to 12? All right, so what is it going to look like? Just a sketch. If this is going to be x, here's 12. Here's the mean of 7 point, whatever that mean was, 97, right? 979, that's just sigma. And now it's going to do like this. But the area under the curve has to be 1, that's where f of y comes in. You all with me? Finally, he asked for it when y is equal to 12, isn't it?
12.
All right, at 12, what happens? Now, it's going to go from 12 minus 6 or 6 all the way out to 18. You all with me on this? I'll go through the whole 9 yards on this and I'll make sure I post. So what's that one going to look like? I start at 6. I go to what? 18, right? Because it's got to have an extent of 12, right? 6 from 18 right here is 12. It'll start looking like this. If you look at this, right here it does something like that, if you look in the, right? Now that will be the density function. And again, what you're doing is you're taking the actual Rayleigh distribution, Rayleigh density function, and you're simply taking a different snapshot and scaling it up so the area under that curve is 1. That's what that f of y is. Do y'all follow me? And that's it. You can literally say, even if you don't know the scale factor involved with this, you can simply take the density function, because the limits are from here to here, integrate this density function, put a k in front of it, and solve for k. Set that equal to 1, you can solve for k without doing all that. But that's what this does right here. This f of y thing, that's all it does, is scale it up. You good with that? Admittedly, it's got a lot going on, but it really, really helps you understand this conditional stuff. I want to do the next one. Okay, and then I'm gonna, does anybody have any specific problem they want me to work besides that one? That's a great problem. Anything? I want to do the next one sequentially. I want to do, and I think I did this one, but I want to do it again. It's 3-2.2, and then I'm going to jump into covariance, and really it's called the correlation coefficient. This is going to make, some of this stuff becomes trivial, well, not trivial, much easier to do once you see what I'm about to show you later. This admittedly gets a little irritating. You know, long ago I had probability. You use this stuff all the time. You use random signals and systems, but when it's applied to specific problems, like in my case, radar and signal processing, usually all the noise that has to do with natural phenomena is Gaussian, almost always. You can turn it into a Rayleigh distribution, it's almost always Gaussian. Almost always, the type of statistical information about the signal has to do with how you created it. If you want the creation of signal to have a constant kind of density function, probabilistic, you can create. If you want to get a bit of skewed density function, like a Gaussian or anything like that, you can do that too. But the nice thing is that with radar, everything is done with friend or foe identification, target and non-target statistic. It's not done with a precise measurement, oh, that's a target, that's not. It's a statistical type of thing. So that's the world I work in, part of my life. What's the next one?
You said you want to do 3-2.2?
Yeah, does anybody mind me doing this? Or if you got another one, just let me know. All these are good problems. Go ahead.
So for the joint probability density function, it is f of x comma y equals kxy.
KXY?
Kxy.
Oh boy. For XY greater than 0, less than 1?
Yes.
Okay, this is the standard, and 0 else, right?
Yes.
Okay, real quick before he goes on, how do you get K, people?
Integral from 0 to 1.
Double integral from 0 to 1 of K, X, Y, dx, dy equals 1, right? What do you get? You get integrate X, you get X squared over 2 from 0 to 1 is 1/2. Y dy is Y squared over 2 from 0 to 1 is 1/2. Therefore, 1/4 times K is 1, or K is 4. I'm gonna go through that one kind of quick. I think you guys got that. You with me? I'm gonna say this right here. Hoping everybody does. You with me on that? All right, what next?
I want you to find the conditional probability density function of f of x given y.
All right, so how do we do it? F of x given y. Well, we know it's equal to f of y given x, correct? Times y. F of x, right? Over f of y, correct? I'm writing it a little quick, but you with me? All right, next part. I've got this, right? So I have f of x comma y equal to 4xy, and this is for x comma y greater than 0, less than 1, right? And 0 else. Okay. Now, how do I get f of y?
Integrate with respect to x. F of x.
Right, and by the way, what's another way to write this? Isn't this just f of x comma y over f y of y, class? Isn't that the same thing?
Yes.
Okay, so I'm gonna get f of y. This is a little easier, less complicated mathematics and conditions, but f of y is gonna be an integral from where to where? 0, 1 of k, which is 4xy, right? dx. Do you agree with that? All right, what's that gonna be? Well, it's x squared over 2 from 0 to 1 is 1/2, or this is equal to 2 times y, right? So that means this conditional probability should be just, here, I have, this is given as 4xy, and I'm gonna just put down x comma y greater than 0, less than 1, divided by 2y, or it's simply equal to what? It's equal to 2x from 0 greater than x less than 1. Do you all agree with that? Now this is an easier problem, but it really just exemplifies what you need to know. Next part is, I think they want the probability, the conditional probability for f of
Y given x.
y, same thing, right? This is f of x given y, f of y given x. The only thing that happens is now this becomes 2y, or 0 greater than y less than 1. The only thing that changed here is the symbolism. Do you all agree with that? What else?
That's it for that problem.
That's it?
That's it. Just-
All right, I got one for you. Listen. Where'd he go? All right, for those that are here, listen. How do I get the mean of x times y? I want the expected value, forgive me, the expected value of xy. People,
Multiply the double angle by xy.
we have x times y times, what is my f of xy?
4xy.
4xy
X,
dy, and 0, 1, 0, 1. I assume everybody can do that without any kind of problems. How do I tell if it is a statistically independent or
f of x, y equals fx of x times f1.
that's one way. What's the way I even gave you a specific problem last, remember I did the factoring? Did you all see the solutions? If you can factor into just a function of x, just a function of y. So take a look at f of xy. Can you factor that into just a function of x and y? You all see it? It's statistically independent. Now that admittedly is a no-brainer. All right? What if it was x plus y?
No.
No. And if you have something where like x squared plus 2xy, and if you have something like x squared plus 2xy plus 3y plus 6,
It is.
Probably.
maybe, because if you factor it, I was brain dead last time, but if you factor it, you get x plus, I think 2 and y plus 3 or something like that. Y'all hear me? If you don't see the punch coming, guys, then you just brain dead, all right?
As long as
This one-
the Rayleigh one's on there.
Is what?
The Rayleigh one on the quiz.
Don't going way out of sight and having a panic attack. Don't need to do it. All right.
No, I have a problem.
Just when I was about to. Go ahead.
Um,
But you all follow me how to get expected.
Wait, but Hold on here. Wait. It's coming. 2 seconds.
2.6? Wait.
And just, can we do a specific problem where the density function is k times,
Is there a problem in the book you're looking at?
yes, sir,
Which one?
3-3.1 word C?
That, okay, hold on. Let me do that one. I'm so glad I got a specific. Then I know people are actually studying and wondering. You know what the worst problems are in that book? The exercises. There's no solutions anywhere, and I work them on that. I didn't get that. And some of them I know are wrong, but some of them I have to go back and think through it, and then I had to do that one time already where I messed up on the board. All right, give me this again, Sam.
This is f of x comma y equal to k quantity
Oh, equal K,
quantity xy plus 2x
XY plus 2X.
plus 3y
I think I said this, didn't I?
plus 6.
Plus 6. Didn't I put this one up?
Yeah.
Or not? For XY equal what?
Greater than 0, less than 1.
All right, let's see if we can play the game. So this is K. Now, I'm looking at this kind of hard here. Is it X plus 3? Maybe. Let's see. X plus 3 times Y plus 2. Will that do it? Let's see. K times, we get XY, right? Then we get plus 3Y plus 2X plus 6. Guess what? Checks that box, right? It's separable. I'm going to just go through them. So in other words, this right here is that for these conditions. Therefore, it is statistically independent, right? Well, now I'm just going through. That's the problem. In a way, I'm glad you asked this because it was literally the problem I was thinking about. So it is statistically independent. Agree? Keep going.
Finding the constant k is like not possible.
How do we find a constant K anyway?
Double integral.
Yeah, I mean, straightforward thing, do a double integral of this with respect to X and Y, right? So when you do it with respect to X, the Y plus 2 is constant. Then you get that integral done, then you integrate with respect to Y, the Y plus 2 is constant, the X plus 3 is constant because it's actually gone, right? And you can everybody follow me on that? How many can? All right, next. You don't even have to do it that way. You can just integrate this thing. What else, Sam?
The expected value of x times y.
All right, great. That's exactly what I wanted. Now, if this is statistically independent, and you all agree it is, right? I can say that this is some K times f of x times g times, or some g times y. Both of these are density functions. I'm just doing it for this way. Do you all agree with this? Now, the expected value of x times y, if they're statistically independent, then you can say that's just equal to the integral of x times f of x. You can put the k anywhere you want. I'll put it here. X times f of x, that's x plus 3, right? Dx from 0 to 1 over where it exists. Do y'all follow me? And it's going to be that multiplied by what?
Expected value of y.
Y, and what's the functional form of y? Plus y plus 2. dy integrated from 0 to 1. Now, what's the value for k in this one? I did this.
4 over 35.
What?
4 over 35.
4 over 35? Is that right?
Yeah.
All right, so if it's 4 over 35, without doing this, how many see that this integration's much easier? Well, I shouldn't say much. It's easier to me than doing it where you get everything multiplied together, right? You're going to save yourself some time. That one's straightforward. This right here is x squared over 2 plus 3x from 0 to 1. This is y squared over 2, x cubed over 3 plus 3x squared over 2 from 0 to 1. And this is y cubed over 3 plus, this is 2y squared over 2 from 0 to 1. You multiply them together, multiply it by k, you got it. Are you with me? Oh, I'm so glad you asked that one. I almost feel like stopping. On Monday, I'll do covariance. I'm going to ask you to go through this. All right, I'll give you a quiz now for only one reason. Some of you may require a little time to think about something. It's nothing tough, but I'm just cutting you a break here. All right, do me a favor, fill up this row. How's this? This row right here where he is, empty this row, fill up this row